So my topic is about finding reliable finding reusable UML sequence diagrams. Finding reusable UML sequence diagrams. So introduction to UML sequence diagrams. UML sequence diagrams are a vital part of a modeling interactions in software systems. They illustrate how objects interact in a particular scenario, uh, showing the order of messages. Understanding their understanding their structure and purpose is crucial for effective use and automation. So challenges in finding reusable diagrams. The sheer volume of UML diagrams can finding UML Importance of reusable in UML diagrams. Reusable diagrams save time and resource in software development projects. They promote consistency across different projects by leveraging proven designs. Identifying reusable components can enhance collaboration among development teams. Uh, if you meant UML sequence diagrams or user SQL diagram templates, these are diagrams that represent interactions within a system in a standardized format, often for software design. UML sequence diagrams are uh, help visualize the flow of messages between objects to components over time. Challenges in finding reusable diagrams. The sheer volume of UML diagrams can make it difficult to locate reusable ones. Variations in notations can modeling styles can complicate the reusability of diagrams. Lack of understanding respiratory hinders the efficient sharing of UML resource. Automation and the diagram retrieval. Automation uh, online UML diagram tools Lucidchat Raw and Creativity offer usable templates for UML diagrams, including sequence diagrams. These platforms can also support exploring and customizing diagrams. Visual Paradiagram has a set of reusable UML templates, including sequence diagram that you can modify for your project. UML template libraries, websites like eDrawMax, Noddraw, and Template.net have downloadable UML templates, including sequence diagrams. Repositories, GitHub, and GitLab sometimes have repositories with UML diagrams, including sequence diagrams, particularly in the repositories related to software documentation. Enterprise architecture software tools like enterprise architecture or IBM Rational Software at Architects offer extensive libraries of UML diagram templates with reusable elements and symbols that you can modify. So automation automation in a diagram retrieval. Automation can significant machine learning algorithms can be employed uh, to different filter and categorize diagrams based on specific criteria. Here is a diagram representing the automation testing process. We have repeat, prepare, write, execute, evaluate, communicate, refactor, and repeat. This is will be the repeat in automation testing process. Automation, the retrieval of a diagram, especially UML sequence diagram, can involve several approaches depending on the specific requirements, such as sourcing from existing repositories, extraction from documentation, or even generating from code. Here is a few automation code approaches. Generating diagrams from code. Tools like Plant UML and or Meramite can generate UML sequence diagram directly from annotated source code. Then next, Intel IntelliJ IDEA, Visual Studio Code, and other IDEs often have plugins for Plant UML or Meramite, allowing you to embed diagram generations as part of the development workflow. And techniques for diagram similarity assessment. Graph-based approaches can be utilized to analyze the structure of UML diagrams. Semantic similarity measures can access the remaining behind the interactions in diagram. Feature extraction techniques can highlight key components for effective comparison. And some are the API integration for diagram libraries. Diagram tools like Lucid Cards, Creately, and Micro Visio offer APIs that can be used to retrieve diagrams programmatically and automate a retrieval and tracing from a respirator. GitHub and GitLab can be automated to retrieve diagrams if they are stored in specific formats like .uml, .png, or .svg. And role of machine learning in diagram retrieval. Role of machine learning in diagram retrieval. Machine learning can train models that to recognize patterns in UML diagrams. Supervised learning can be used to classify diagrams based on historical data. Unsupervised learning might uncover hidden similarities in an unlabeled diagram. uh, Machine learning can play a significant role in diagram retrieval, especially aspect of systems that need to recognize, classify, and extract meaningful information from visual or structured representation like UML diagrams. And extensing tools and frameworks. Several tools exist that facilitate the automatic retrieval of UML diagrams. Open source framework can be customized to suit specific project needs. Commercial tools often come with advanced features for better usability and integration. Diagram classification and identification, image classification. Convolution neural networks can classify diagram by type to enable easy organization and retrieval. And coming to another one is the object detection. ML models like YOLO or Faster or CNN can identify specific components in diagrams such as actors, objects, or arrows in sequence diagrams, making it easier to categorize and index these diagrams. Uh, Criteria for diagram reusability. Diagrams should be evaluated based on their clarity and comprehensibility. The context in which a diagram was created impacts its potential for reuse. Compatibility with the current project requirements is crucial for successful application. And building a repository of reusable diagrams. Creating a centralized repository can enhance accessibility reusable diagrams. Standardization of diagram formats can help maintain consistency in the repository. Regular updates and evaluations can ensure the repository remains relevant and useful. Metadata and annotation strategies. Adding metadata to UML diagrams can facilitate easier searching and categorization. Annotations can provide context and usage examples for potential users. Well-documented diagram can significantly enhance the reusability. User-centric design in the diagram retrieval systems. User interface should be initiative to encourage widespread adoption of retrieval tools. Feedback mechanisms can improve the system based on user experiences. Customization options can cater to different user roles and project needs. Case studies of successful implementations. Several organizations have already successfully implemented automated retrieval systems. Case study highlight the benefits of reusability in large scale projects. Lessons learned from these implementations can guide future efforts in this area. So here is a cross case complication factor, case A and case B, and future trends in UML diagram reusability. Increased integration of AI and deep learning techniques is expected in diagram retrieval. Cloud-based solutions may facilitate better collaboration and sharing of diagrams. Emerging clouds streamline the process of diagram creation. Coming to the conclusion and the key takeaways, the automation of finding reusable UML sequence diagram presents significant advantages. Overcoming existing challenges requires a combination of technology and best practices. Emphasizing reusability can lead to more efficient and effective software development.